All right, welcome in. Today we are talking about angle relationships. So we've got a few terms to go over and then a few examples to work. So the first thing we want to look at is adjacent angles. So whenever you see this word adjacent, it means that the angles are next to each other. Well, what does that mean? It basically means that they share a side. So if we remember from last time, we were talking about how sides are the rays that come out of the corner of the angle or the vertex. So we notice how in this picture 1 and 2 have the same middle line, that same middle ray. So 1 and 2 are adjacent angles. The picture on the right, we notice how angle 3 is over here. ABC is over here. They do not touch, right? They don't share a side, so they would not be considered adjacent. So when you see this non-adjacent, that's what that means. A linear pair is a pair of angles that make a line. Right? So remember, we've said before that in math, our terms are usually really descriptive. So linear pair, again, pair means two. Linear means make a line. So a linear pair is a pair of angles that makes a line. They will be adjacent. So if we look at the example, we notice how the two angles share this ray in the middle. If I follow the other two rays, they're pointing in the opposite directions, so they're going to make a straight line. The picture on the right, we notice we can't take any of the three rays and turn them into a straight line, so this is not a linear pair. Finally, vertical angles, right? So vertical angles are non-adjacent angles formed by intersecting lines. Now that's kind of confusing. The way to remember this is vertical starts with V. So your two vertical angles are going to appear as opposite V's. In other words, it's two V's. So here's a V. Here's a V. That face the opposite direction. So if I look at the example, 1 and 2 are vertical because when I draw them out, there's a V going up and a V going down. 3 and 4 are vertical because the V's point on the side. We notice that for the picture on the right, they are not vertical angles because the line from B to E to D is actually crooked, so it's not a true line. So you notice the difference in the pictures is that on the left, both lines are perfectly straight, forming an X. On the right, it almost looks like we have two lines, but E to D is slightly crooked, so that doesn't work. Let's look at an example. So we have this picture, right? We have a bunch of lines going through each other, so we've got several angles that have been formed. The first part asks us to find two acute adjacent angles, right? So we said acute angles are less than 90. Adjacent angles are next to each other. So we need two angles that are acute. So I'm going to just pick an acute angle. So remember, when we're naming them, we pick the letters in the order that we pass through them when we trace it out. So it would go from O to J to N. So I have O, J, N, and I put a little angle sign in front so I know I'm talking about an angle. we said in order for it to be adjacent, it has to share one of the sides. So we notice this line here is in both the angle we just drew and that angle in the middle. So what points did we pass through to trace that angle? Well, we passed through N, J, and M. So the second angle that's part of that pair we said was N, J, M. Alright, so for the next one, we need two obtuse vertical angles. So again, we want to pick out an obtuse angle, which if you remember, we said was an angle that's bigger than 90 degrees. So let's say we pick this one. So which 3 points did I pass? Well, I passed through K, J, and L. So again, that's K, J, and L. And now I need another angle that is both obtuse and makes a vertical angle. So, if we look at the picture, think of our angle we just drew as facing to the right. It's a V facing to the right. So I need to copy that exact same V, but have it facing left. So I see it here. The whole thing forms an X. Everything looks straight. The V's are facing opposite ways, so we have found our vertical angles. It looks like to get the right angle, or the correct angle, I have to pass through H, J, and O. So my angle, again, is H, J, O, and there we go. Alright, so for the linear pair, and for the two acute vertical angles, I will let you try to figure those out on your own. Okay, so the next thing to talk about. We may have noticed this when we were tracing these out, but vertical angles are congruent. And remember, congruent simply means that the angles have an equal measure. So think congruent means equal. And we can kind of tell that by looking at the picture, right? If I draw out the two V's, the opposite V's are the same size. If I draw it going sideways, I have two smaller V's, but both V's are the same size. Okay, two other terms. Complementary angles and supplementary angles. So if we remember, complementary angles add to 90 degrees. So we can say they add to 90. Supplementary angles add to 180 degrees. So if you look at the two examples that they give you in the boxes, 65 plus 25 equals 90. And 120 plus 60 equals 180. So any angles that add up to 90 will be complementary. Any angles that add up to 180 will be supplementary. And finally, if you have a linear pair, it's always going to equal 180 degrees. So if I look at angles 1 and 2, I know if I go rotate from angle 1 through angle 2, it's going to be 180 because that's my rule. Alright, so let's look at an example. We need to find two supplementary angles. If the measures of the two angles, the difference in the measures of the two angles is 18. So remember, difference is the answer you get when you subtract. Or another way to think of it is one angle has to be 18 degrees bigger than the other. So we said supplementary means they add to 180. So when I draw my two angles. I'm going to have a small angle, and then I'm going to have another angle that's bigger by 18 degrees. So, how do I find this? Well, we said supplementary angles have to add to 180. So I take my two angles, add them up, and make them equal 180. So we're just going to simplify and solve. So x plus x gives me 2x. Subtract my 18. Eighteens cross out. And finally, divide by 2. So that means x equals 81. Notice it said we need to find the measures of both angles. So 81 degrees is one of the angles. We notice the other angle was x plus 18. So to figure out the other one, 81 plus 18 give me 99. So my two angles are 81 degrees and 99 degrees. And if I want to double check myself, 81 plus 99 does equal 180, so we know we did it right. Alright, so go ahead and try the next one on your own. Okay, so the last thing to talk about is perpendicular lines. Right, so perpendicular lines create right angles. So we know it's a right angle because they're going to mark it with the little box. When you see this upside down T, that's the symbol for perpendicular, so we don't necessarily have to write that long word out every single time. So in example 3, it wants us to find x and y so that the angles make 90 degrees, so the lines are perpendicular. So we just have to solve it out separately. So I notice 4y minus 2 needs to equal 90 degrees. So we can go ahead and solve for y. Right, we're going to add 2 to get 92, and then divide that by 4. So we should get 23. Notice I solved for y first because it had less stuff on it. Finally, let's get x. So in order to get the right angle over here, notice that these two would have to add up together. So we're going to take our 2x plus our 5x plus 6 and have it equal 90. So let's solve it out. Subtract the 6. Divide the 7. And there we go. So that's all for today. I'll see you next time.